talk about something called variation today. We talk about this around the time that we talk about rational functions because variation is an example of usually a sort of a practical rational function, particularly inverse variation, which we'll see in just a minute. So when we talk about variation, we're looking at this idea of two different variables that impact one another. So when this thing goes up, this other thing also goes up. Or when this thing goes up, this other thing goes down. We see some sort of relationship between these two things here. Direct variation between two variables means that they both increase or both decrease together. So I would see some relationship like this. When variable A is low, variable B is also low. When variable A is high, variable B is also high. Okay, so they increase or decrease together. Inverse variation is a relationship between two variables where they do opposite things. So if variable A is low, variable B is high, and vice versa. When the value for variable A is high, I would expect the value for variable B to be low. So when one goes up, the other goes down. They do the opposite. They do the inverse of one another. We're going to look at a few examples of variations together, and then I have an activity for you for today. So these are all sort of with a context, so we're not looking at hard numbers, we're just looking at what would I expect to happen. So for our first example here, it says the number of days after a haircut and the length of my hair. So those are my two variables. How many days it's been since my haircut and the length of my hair. So right after I get a haircut, would I expect my hair to be super long or shorter? Shorter, right? And that's all relative, right? If I got a haircut, it's shorter than it was before. I can still have long hair. What about as time goes out, as time passes? What happens to my hair? It gets longer. The more days it's been since I had a haircut, the more my hair has had an opportunity to grow, right? So I would get a relationship that looks something like this. If it's been a while since I had a haircut, right, it'll get a little shaggy, right? The hair gets longer. That is an example of direct variation. Let's talk about something you are hopefully not familiar with. Number of speeding tickets and the cost of car insurance. If I've had no speeding tickets, would my car insurance be high? Relative, no. What if I've had a few tickets? What happens to that car insurance? Starts creeping up, right? If I've had a lot of tickets, it gets pretty expensive. That's another example of direct variation. No one in here is aware of this. No one has ever had this happen to them, right? Just let me believe that. But yeah, or if you've had a lot of accidents, especially if you were an at-fault driver in an accident, that cost of car insurance is going to go up. Let's say the speed that you drive and the time it takes to get somewhere. Again, none of us are familiar with this. So the speed that you drive and the time it takes to get somewhere. If I drive slow, is it going to take me a short time or a long time? A longer time, right? If I drive faster, it takes me a shorter time, right? So my time to get there is going to be lower the faster that I drive. If we switched them, so time and speed, when my speed is high, my time would be low. When my speed is low, my time would be high. So it would still look like this, even if I switch those variables. Bless you. So this is an example of inverse variation. Inverse variation. So for these first two, we have this sort of, can you point it out, sort of the slope that we're seeing there? We have this kind of positive slope that we're looking at. When these values are low, these values are also low. When these values are high, these values are also high. For number 3, that's the opposite. When these values are low, these values are high. When these values are high, these values are low. So that's inverse variation. Number 4, good question for February. Outside temperature and the amount of clothes you wear. So last week we had all that snow and it got pretty cold. The temperature was low. When I went outside, I had on like a hat and like my like thick like outside play in the snow pants and gloves and all that good stuff, right? Bunch of extra stuff. In the next week, it's supposed to warm up into the 50s, right? I won't need like the heavy winter coat then, right? Just like my medium winter coat. Or when it's really warm outside, when we finally get to spring and summer, right? Shorts and a t-shirt. I don't need long pants. I don't need a coat. I don't need a hat. So the warmer the temperature is, the fewer things I have to worry about bundling in to go outside. That's another example of inverse variation. Inverse variation. And then number 5, time spent studying and your grade on a test, what you would expect. So time and grade. We're talking algebra 2 here. If I spent no time looking over problems, asking questions, what would I expect out of my grade? I didn't do any of the homework. I would probably expect that grade to be low. If I did my homework, I spent time on the review, what would I expect? A higher grade, yeah. That is direct variation. Okay. So direct variation, my variables go up together, go down together. Inverse variation, one thing goes up, the other thing goes down, and vice versa. Now, we can also have multiple variables that impact one another altogether. That's called joint variation. So that's when I've got 2 or more direct variations. So maybe it's time I spent studying and number of questions I asked. The more of those things that I did together, the better my grade was. That would be an example of like joint variation. We could also have combined variation. So I could have, again, multiple types of variation all present within the same problem. Most of what we're going to see is going to be either direct or inverse, but it is possible that we've got joint or some combined variation happening. Questions for me so far? Okay, so here's what we're going to do next. We're going to split up into groups here in just a minute. And then on the next page, I want to talk through the activity we're going to do with you really quickly. So the idea is we're going to look at something called perceived height. So you know when you stand really far away from someone, you can like get their head between your fingers, right? Or like people like to go to those touristy places and take photos, like the Leaning Tower of Pisa, where they're like pretending to hold it up, or like, look, I'm holding the Eiffel Tower, right? That's perceived height, right? It looks really small because you're way far in front of it. So what we're gonna do is an activity with perceived height. All your directions are here. Make sure that we're using meters and centimeters on our rulers and meter sticks that I'll hand out in just a second. But what you're going to do is at several different distances, you were going to measure the perceived height of your partner. Okay, mark it down. And then you are going to answer some questions about what type of variation that you're seeing. Is this direct variation? Is this inverse variation? What's happening here? Okay, questions for me right out of the gate? Okay, so we will get started with our activity.
So phone cameras and just kind of like take a ruler and